Every host we have used so far has an MCP client built in. Claude Desktop, Cursor, VS Code. They all implement the protocol for you. But what if you want to call your MCP server from a Python script, a web backend, or an automated pipeline? In this episode, we build our own MCP client from scratch. It connects to any server over stdio, performs the full handshake, discovers tools, and calls them programmatically. There are 5 good reasons to build a custom client. You want to call MCP tools from a Python script or automated pipeline without opening a graphical user interface. You are building a web backend that needs tool access. You want full control over the agentic loop, including retry logic and error handling. You want to test your servers programmatically in continuous integration. Or you are building a multi-server orchestrator with custom routing that no existing host supports. The MCP client class stores the command and arguments needed to launch the server process. It keeps a reference to the subprocess, the reader and writer streams for standard input and output, a counter for JSON-RPC message IDs, and a list of discovered tools. We use async I/O streams rather than subprocess pipes directly because our client is async, and async I/O streams integrate cleanly with await-based code. The connect method launches the server as a subprocess using async I/O create subprocess exec with standard input and standard output set to pipe. This gives us async streams we can read and write. The send method builds a JSON-RPC request with the next available message ID, serializes it to JSON, appends a new line as the message delimiter, writes it to standard input, and drains the buffer to ensure it is sent immediately. The receive method reads one line from standard output and parses it as JSON. One line equals one JSON-RPC message because we append a new line delimiter when sending. The initialize method sends the initialize request with the protocol version and client info, reads the server's capability response, sends the initialize notification to complete the handshake, and immediately calls list tools to populate the tools list. After initialize returns, the client is fully ready to use. ListTools sends the tools/list method and extracts the tools array from the result.callTool, sends the tools/call method with the tool name and arguments dictionary, then extracts all text content items from the response and joins them into a single string. This gives us a clean string result we can pass directly to a language model or print to the terminal. Here is the client in action. We create an MCP client pointing at our file system server, connect and initialize, then print all available tools and their descriptions. We call list directory with a .path to list the current directory and print the result. This is now a fully functional programmatic MCP client. We can call any tool on any server from a Python script with 3 lines of setup. To wire the client to a language model, we convert the MCP tool definitions into the format the Anthropic SDK expects. The main differences are that Anthropic uses input schema with underscores rather than the camel case input schema from MCP, and the tool list is passed as a separate argument rather than embedded in the prompt. The Tools for LLM helper does this conversion by iterating the client's tool list. The agentic loop sends the user message to the language model with all available tools. If the model returns N, turn the loop exits, and we return the final text. If the model requests a tool call, we extract the tool name and input from the response block, call it through our MCP client, and append both the assistant's tool use request and the tool result to the message history. The loop continues until the model decides it has enough information to answer. You now have a working Python MCP client that launches a server process, performs the full protocol handshake, discovers tools, calls them programmatically, and drives a complete agentic loop with a language model. In the next episode, we extend this to multiple servers simultaneously. One client that connects to all your servers, routes tool, calls to the right one, and gives the model a unified tool list from the entire fleet. Subscribe so you do not miss it. See you in the next one.